Lesson 7.3 Agricultural Meteorology and Technology. Main topic: Agricultural Meteorology and Technology. Subheadings: What is the agricultural meteorology and technology role of weather in agriculture? Use of technology in precision farming. Weather and risk management in agriculture. Agrometeorology is the branch of science that studies weather and climate conditions affecting agricultural activities. Meteorological data is essential for efficiently managing agricultural processes such as plant growth, sowing and planting times, irrigation, fertilization, and harvesting. The integration with technology makes these processes more precise, productive, and sustainable. For example, satellite imagery and sensors allow real-time monitoring of data such as soil moisture, temperature, wind, and precipitation. Smart farming applications and artificial intelligence enable automatic irrigation or fertilization based on weather forecasts. Drones are used for field observations, allowing early intervention in problems such as diseases or drought. Thanks to this integration, farmers can reduce risks and achieve higher yields with fewer resources. Now let's examine this issue in a little more detail. The agricultural sector is fundamentally influenced by meteorological conditions. Weather can affect every stage of crop growth, from planting to harvesting. Factors such as temperature, precipitation, humidity, wind speed, and solar radiation directly impact plant growth, soil conditions, and pest dynamics. Farmers adjust their agricultural practices based on weather patterns and conditions. However, with climate change, the unpredictability of weather events has increased, raising the risks in agriculture. In agricultural economies like Turkey, meteorological conditions play a critical role in shaping agricultural policies and determining productivity targets. Temperature ranges and plant growth. Each crop species has a specific temperature range in which it grows optimally. Deviations from this range can lead to suboptimal plant development and reduced yields. Statistical data. In 2023, Turkey recorded an average temperature increase of 1.2 degrees Celsius above the long-term average. Heat stress and yield loss. Heat stress, especially during critical growth stages such as flowering and fruiting, can negatively impact crops. High temperatures increase plant water requirements and can interfere with cell division and nutrient uptake, leading to decreased productivity. In 2022, wheat production in Europe saw a 10 to 15% reduction in yield due to prolonged heat waves, highlighting the vulnerability of staple crops to extreme temperatures. The role of precipitation in crop development. The amount and timing of precipitation are critical for crop growth, particularly in rain-fed agricultural areas. Adequate and regular rainfall ensures soil moisture and meets the water requirements of crops, boosting productivity. However, irregular rainfall and excessive precipitation can lead to flooding, soil erosion, and plant diseases. Irregular rainfall and water stress. Irregular rainfall distribution can cause water stress in crops, especially during critical growth stages. Water scarcity can slow down plant growth and reduce yield quality. In 2022, the Göller Yöresi, Lakes region of Turkey experienced a 30% yield loss in rain-fed areas due to irregular rainfall patterns that negatively impacted wheat and corn production. Climate change and its effects on agriculture. Climate change has led to an increase in extreme weather events, making agriculture more vulnerable. Events such as frost, hail, sudden temperature changes, and prolonged droughts can result in significant yield losses. Between 2022 and 2024, 54% of reported agricultural disasters in Turkey were caused by droughts and temperature fluctuations. Agricultural irrigation and water. Water supply is very important in agricultural activities. However, irrigation can be difficult in arid regions. Factors such as increasing temperature or decreasing rainfall are important in irrigation. Turkey's total water potential is about 112 billion cubic meters, but only 44 billion cubic meters is available for agricultural use. Precision agriculture is an approach aimed at increasing agricultural productivity, using resources more efficiently, and reducing environmental impacts. The rapid development of technology plays a significant role in the adoption of precision agriculture practices. These practices are supported by tools such as advanced sensor technologies, satellite imaging, drones, IoT, Internet of Things, and data analysis software. Sensors and IoT technologies. Sensors are used to measure environmental factors such as soil moisture, temperature, pH levels, and nutrient content. These data are utilized to optimize the water and nutrient requirements of crops. According to a 2022 study, the use of sensor technologies reduced water usage by 25% and increased fertilization efficiency by 30%. Satellite and drone technologies. Satellite imaging and drones are used to monitor crop health, analyze the status of yields, and combat pests. Drones provide high-resolution imagery, allowing farmers to closely observe their fields in detail. Automation and robotics. Automated irrigation systems, fertilization systems, and robotic equipment are used to make farming operations more efficient. These technologies reduce labor costs while enabling high productivity in agricultural fields. Increased productivity. Precision agriculture technologies constantly monitor plant growth conditions and health, offering opportunities to enhance agricultural performance. As of 2022, precision agriculture methods resulted in a 20 to 25% increase in agricultural productivity. Significant yield increases have been observed in staple crops like wheat, corn, and soybeans. Loss and risk management. Precision agriculture enables farmers to detect potential losses early. Risks such as pests, diseases, or adverse weather conditions can be controlled quickly, minimizing yield losses. Agriculture is a sector that is directly dependent on environmental conditions. Weather, in particular, is one of the most critical factors influencing all stages of agricultural production, from sowing to harvest. With the increasing impacts of global climate change, weather-related risks in agriculture have become more evident. Drought causes significant crop losses, especially in areas with limited irrigation possibilities. According to the FAO, droughts between 2005 and 2020 led to an average 34% decrease in agricultural output globally. Sudden frost and heat waves. Frost events pose a high risk for fruit trees and early sown crops, while heat waves negatively affect plant metabolism, causing developmental disruptions. The 2022 heat wave in Europe caused a 16% drop in corn and sunflower production. Eurostat, 2023. Excessive rainfall and flooding. Heavy rainfall can lead to soil erosion, root rot, and fungal diseases, thus reducing crop quality and yield. According to the World Bank, floods between 2018 and 2022 directly affected 12% of agricultural lands in South Asia. Meteorological early warning systems. Automated meteorological stations and alert systems help inform farmers of potential weather events in advance, allowing them to take preventive measures, satellite-assisted weather forecasting and field monitoring. High-resolution satellite data enables precision irrigation and pesticide application based on real-time weather conditions. Weather data combined with soil moisture analyses also enhance the accuracy of yield forecasts.